And the first one is by Phillip.
Thank you. Hi, I'm Phillip Alday. I'm presenting my package today, BoxCox.jl. It's a lightweight package with nice extensions, is my claim. It implements something called the Box-Cox transformation, which is a way to kind of get normality in a distribution. So it looks at the set of possible power transformations, and it tries to propose a way for you to get your data to be more normal. This is, of course, very useful in linear regression. I'm not going to go into the math here, but it also will give you the log as a special case. As an example, this is a normal distribution that I have squared, and you can see that the square of a normal distribution is indeed not normal. And with BoxCox.jl, you can just fit the BoxCox transformation, and it will give you an estimate of this. It doesn't come back as 0.5 exactly. That's life with real data. But it does this, and it uses kind of the StatsAPI fit syntax. This is where we start seeing kind of the nice extensions that I was talking about. There's a Makie extension, and so then you can use BoxCox plot, which actually plots the likelihood profile for the transformation. And so you can see what values are used. And so you can see that the maximum is achieved at around 0.2 and change, but there's also a 95% confidence interval on this. This is very comparable to BoxCox and our package MASS. And so if you have an appropriate Makie backend, you can do this. And we can also fit it and apply the transformation. And you can see that the returned object is a callable object, and so you can broadcast it, and then wham, bam, you have your transformed data. Very easy. More interesting is that you often want to do this for linear regression of some type, and so you want to look at conditional distributions. And you can do this quite simply. This is, again, an example I borrowed from the R world, looking at tree data. It's growth, height, and volume of trees. And the best model that they discovered empirically is that basically you log transform all these things. So I very cautiously constructed a model matrix with an intercept log transforming the height and girth, and use that to predict the volume of the tree. And what you see with the diagnostic plot is that you get an empirical estimate of negative 0.1, but 0.0, so the log case is well within the 95% confidence interval. And so that's actually what we'd use in practice. We wouldn't choose the MLE here. We just use the one that actually fits well scientifically, bringing in some expert knowledge. But this is kind of annoying to build your own model matrix, and we have a nice package for that in Julia, StatsModels.jl. And so if you've loaded stats models either directly or because you have GLM.jl loaded or you have MixedModels.jl loaded, you can use the formula syntax. And you don't pay a cost for this because, again, it's a package extension. So if you're not using stats models, you don't pay a cost. But if you are, you get this nice little treat. This also works for mixed models, which is something that the R universe only very recently got. I think they took the gauntlet being thrown down. So this is a mixed effects model looking at reaction time and sleep study. Test subjects were deprived of sleep, and their reaction time went down the longer they went without sleep, unsurprisingly. If you actually fit the regression model here, there's a couple of little problems. But what we can do is we can fit the regression. We can fit the BoxCox transformation, and again, we just call fit BoxCox transformation, and then we pass it the mixed model we started off with. And it fits it, does it relatively quickly. Again, this is a package extension, so you don't pay the cost if you don't have it, but if you do have it, great. And again, kind of highlighting something empirical about this is that time minus, so the inverse of time has a natural interpretation of speed. It's well within the 95% confidence interval, so rather than using the empirical estimate of minus 1.1, we typically just use minus 1, and then we interpret it as responses per second instead of the amount of time needed to response. And so in this case, I have to add in 1,000 into the numerator because the original data are milliseconds and not seconds. Easy. And then we get this nice model. Everything works out. We're happy. And that's actually it from me. As I said, it's a nice little package and it has good extensions. I'm happy to take any questions. It's all linked on pre-talks, by the way. So if you go there, you can actually see all this. And if I went too fast, you can look there. And it's also done as a nice article thing. Thank you.
Thank you. What are your questions? So, can you remind me how I do? I mean, what kind of data would I want to fit with this transformation?
Well, it'd be very typical that like you're fitting a linear regression model of some type, whether mixed or classical, and your data aren't, like the residuals are not normal, and you don't want to like kind of just pick a transformation out of the hat. And so this kind of suggests like maybe you should take the log of the data, maybe you should take the reciprocal, maybe you should look at the square of the data, and this will help you figure that out. So that's the idea behind it. It's actually a very old technique, like the from 1964, and it's not really taught anymore, unfortunately. But I think it's pretty cool.
Okay, great. Thank you.
Thank you.
There's one question.
So you can fit the Box-Cox transformation on already on a model, right?
Yep.
And if the model has several covariates, what does it try for each covariate?
Oh, so what it does is it does the different transformations, so the different possibilities, and then it's a nonlinear optimization problem. So it does a transformation, and then it refits the model on the transformed data. And so then you get new estimates for that. And then it does the next possible transformation and does this. It doesn't actually do like a grid search. It properly uses a nonlinear optimizer.
Isn't it a multi-dimensional search if you have several covariates, which you can box?
So you do the transformation and then you fit the model. So you do transformation model fitting. In the model fitting process, it just uses MixedModels.jl or GLM or whatever. And it's just that model fitting process. So the search space is the search of possible transformation values, the lambdas.
On each.
And then you do the maximum likelihood fit on each of the lambdas.
So it's on each covariate?
It's searching over the space of possible lambda values. So if you look like here, this is the search space.
Or just on the dependent variable?
Just on the transformation. So it's doing a transformation and then refitting the model each time.
Okay, so there's...
Yeah, you're transforming the response.
The response, yeah, but you can also transform the inputs.
This does not, the Box-Cox transformation does not touch the inputs.
Okay.
This is purely on the response.
Thanks.
Thank you. Then let's thank the speaker again.